How are we doing, guys? We are looking at equations with indices today. So that's an equation that might look like this. 2 to the power of x equals 8. And the answer, you have to find out, well, what value does x have? Okay, now you might spot that and you might go, well, it's 2 cubed. So 2 to the power of 3 equals 8. So you might say, yeah, x is 3. How do you get there? You'll say 2 to the x is the same as, change that 8 to base 2. So 8 is the same as 2 by 2 by 2 is 3. And you say, well, x and 3, they're the same thing. So x equals 3. A little bit trickier here. If it says 4 to the power of x equals 32, well, 4 by 4 is 16. So no, it's not 2. And 4 by 4 by 4 is 64. So it's not 3 either. So somewhere between the two of them. How do we find it? You write both numbers to base 2. So 4, you say, well, 4 is 2 squared. So that's 2 squared to the power of x equals, and 32, you'll say 2 by 2, 4 by 2, 8 by 2, 16 by 2, 32. That's 2 to the power of 5. Now, if you write that out according to our rules, that's multiply the indices. That says 2 to the power of 2x. And we're getting into maybe slightly tricky algebra now, but 2 to the power of 2x is the same as 2 to the power of 5. When you get to this stage, just like up here, you had the same basis on both sides, 2 and 2. Same here, we've got the same basis on both sides. Now you can say, well, 2x and 5 have to be the same. Hopefully you can say, well, if 2x equals 5, divide across by 2, x is 5 divided by 2 is 2.5. Now, just go to your calculator, put in 4 to the power of 2.5, and you should get 32 as an answer. So you can check these, see if you've done them right. Here's another one, same type of thing, quite tricky, okay? So maybe pause the video. Write 25 as 5 to the power of something, and 125 as 5 to the power of something. See how far you can get. Okay, hopefully you've given that a go. You've said 25 is the same as 5 squared, and 125 is the same as 5 cubed. Okay, this now says 5 squared to the power of x equals 5 cubed. And that's the same as 5 to the power of 2x, multiply your indices, an index to the power of an index, equals 5 cubed. And now you can say, well, those two indices have to be the same. Okay, so 2x has to be the same as 3. You're kind of starting nearly a new equation here. You're saying these two things are the same. 2x is 3, x equals 3 over 2. Okay, or 1.5. Again, go to your calculator and try that. 25 to the power of 1.5. You should get 125 as an answer. Next thing that you'll be asked to do some places in this exercise is to take a number like this and write it, say, as a power of 2. But geez, how do I do that? So you break it up, you say, well, 8 as a power of 2. Well, that's 2 by 2 by 2 is 8. So that's 2 cubed multiplied by 2 square root of 2 as a power of 2. Now that's our fractional indices that we saw in the last exercise. That's 2 to the power of 1/2. And then if you go back to our rules, when you're multiplying numbers with the same basis, you add the indices. So that's 2 to the power of 3.5 or 3.5, whichever you prefer. 3.5 is fine as well. Okay, this one here, you might try it yourselves if you think you can. I'll take a break. Okay, let's see how we did. 16 is 2 to the power of 4, because 2 by 2 by 2 by 2 is 16. On the bottom, same as up here, that is 2 to the power of 1/2. Okay, but now our rules say you subtract, if you're dividing one number by another number and they both have the same basis, you subtract the indices. That's 2 to the power of 4 minus 1/2, or 2 to the power of 3.5 again, 3.5. Same as up here. So actually these are the same number, just written in different forms. Okay, now this one genuinely is quite tricky. So I'm going to say this, I'm going to do it now. Okay, but you might need to come back and watch it again when you get on to, I think it's question 10 in this exercise. 9 as a power of 3. So everything here is base 3. So you can say, well, that's 3 squared to the power of x plus 1 is the same as 81 is 3 by 3 is 9 by 3 is 27 by 3 is 81. So that's 3 to the power of 4 divided by 3 to the power of 1 half. So what am I getting here? Well, multiply out my indices here. That says 3 to the power of 2x plus 2. And here I say 3 to the power of 4 minus a half. Okay, subtract the indices because you're dividing. That's 3 to the power of 3.5. Okay, so we're trying to work out what value x has. We put the two equations with the same basis, which means the indices now, just like over here, if you've got the same basis, the indices have to be the same. So you say 2x plus 2 equals 3.5. Then you need to solve this equation. So plus 2 on the left becomes minus 2 on the right. That's 1.5. And then divide through. X is 1.5 divided by 2 is 0.75, or 3 over 4. Okay, if you wanted to work in fractions. Now, that's genuinely hard. If you didn't follow that, not the end of the world. Can you go now to page 332 and try questions 1 and 3? Okay, tomorrow in class, we're going to look at questions 2, 4, 5, 6, 7, and 8. Okay, so we won't even get as far as this, but we might be looking at that example again. Okay, thanks, guys.